So to begin with, all I'm asking is that you have that formula memorized and that you take this function, figure out what A, B, and C must be, and put them in and simplify it. These take a while, I know, so I'm going to give you a bit. Now, would you agree that you don't give people high-level tips until they at least have the basics down? So I'm about to start today dropping on you like, okay, it'd be really smart if you do it this way. Like what order you should do this thing in. Because you can do it any way, as long as you stick the numbers in the formula, but you usually don't give people the pro tips until they're at least past the basics. Do you remember me telling you yesterday where the most mistakes are made? I should have done it this way. I would have remembered it better. In the red zone. Most mistakes are made in there. So if I bet if anybody has a mistake today, right now, it's going to be because you screwed up that number. All right, so it should be -8 is the B. So it's negative of -8, which makes positive 8, of course. 8 squared, -8 squared technically, but the negative will fall off when you square it. Minus 4 times 1 times -9, and that's 2 negatives. Did you notice that means plus? All over 2 times 1. So 8 plus or minus the square root of b squared is 64 minus, which means plus 36. Ooh, that worked out nice. Why did I say that worked out nice? What's that actually underneath the root? 100, and it's the square root of 100, which is, so it's 8 plus and minus 10 over 2. And if you get it that far, I can give you part credit. And I can't give you the full credit. Lydia, what's the final on this?
So you have to do it 8 plus 10 over 2.
8 minus 10 over 2. And that gives us 18 over 2, which is 9. And 8 minus 10 is -2 divided by 2 is -1. Boom. 2 answers. How many of you had those 2 answers? Okay, awesome. Now, pro tip. Why do you think I'm going to suggest that you always do this part of the equation before you do the rest of it? Because what if it comes out negative? Do you get it's the square root of a negative and then the whole thing's not going to work? You see why that would be smart? And also, if it's the hardest part, you can like really concentrate on getting that b squared minus 4ac right. All right, here's another couple little tips. Remember how to do this?
What happens if it's negative? Like what you write?
Okay, that's what we're going to do right now, in fact. So if I had square root of 60, but that'd be fine, I could simplify it. But if it's square root of -60, in the old days when you were in algebra, they'd be able to say, you just can't do square roots of negatives. But now, today, we need to move on from that and be able to go, actually, I can handle that. That negative means that the answer is imaginary. So it's going to be I and the square root of 60. And then I'm going to see if I can simplify it more. I know root 30 and root 2 works. But that doesn't, yeah, neither one of those really works. I mean, I root 30 root 2, it isn't any better. So here's a trick for you, pro tip. If 4 goes in, we all know 4 would be a good thing to check, but nobody likes to divide 60 divided by 4. If you can divide 60 by 2 twice.
15.
See, does 60 divided by 2 once? Yeah, it's 30, but does it divide by 2 again? Yup, and that means it's 4 and 15. See what I did there? I cut it in half twice, and that meant 4 went into it. So 4 times 15 is 60. Yay. So then this is 2 root 15. What about the I, though, Mr. Server? Yup. There's an I in there. Why? Because it was a negative in the first place. Okay. So there's different levels. Some kids don't know how to do the square root of 25. Yeah, you're probably toast on this whole test. Okay. But if you can do that, can you also do it if I make it negative 25? Everybody write down what you think the answer to that is. And in a moment, I'm going to ask you to compare with the kid next to you. Pausing. And 5i is the easy way to just say, oh, it's 5, but it's imaginary. But what really is happening is you're doing the square root of 25 and the square root of negative 1. And this one is what scientists, I think, were the first ones to do this, or a mathematician, I'm not sure. They decided we're going to say that the square root of negative 1 is I. So that's I, and that's 5. That's why it's 5i. Because the square root of negative 1 is what I is. All right. Now, here's another pro tip. You get to the end and you're doing one of these. 10 plus and minus the square root of 8. You did a whole bunch of work to get here. And then you get this. And a ton of kids are going to be stumped right there because they're like, I thought that was the answer. But no, it can simplify more. And here's what gets people. It's not so much this. Most of you can change that into like, I don't know, 3 root 2 or whatever it is. You'll figure it out. But most kids don't notice that the top can be factored and then canceled with the bottom when it's factored. All right, so start with this, rewrite it, see if you can factor it and cancel. And I'm not sure if this is going to be extra credit on the test or if this is going to be something you just have to do to get full credit. Maybe you get part credit for getting this far and full credit if you can finish. What I was advocating for is maybe we could make it extra credit if kids could do this last step. But I want to teach you either way. So in case you haven't got this far, this is root 4 and root 2, which is 2 root 2. Then you rewrite the problem with the 2 root 2 there, and you see if you can factor it. Factoring skills are the number one thing. I've told you that before. The most important thing. All right. Simplify the one that's on the board. If you're having trouble, start by writing it down. (10 plus and minus 2 root 2 over 12 is a good start. Then this both has a 2 in it. That's the hardest thing, is to go 5 plus and minus root 2. Because on the bottom, you'll all figure out eventually that 2 times 6 is 12, so then you can cancel the 2's and you're done. So the only hard part was the top. Did anybody get this far? 5 plus and minus root 2 over 6. Nice! It's a lot of you. I must have done that before in here. But I was not expecting that many people to get it right. All right, let's try one more. 3 plus and minus the square root of 27 all over 6. You worked hard. You got the problem down to this. You did the discriminant, which was 27. And then you're like, oh, I know I'll get either extra credit or full credit for reducing this. In a moment, I'll have you compare with the kid next to you.
I turned square root of 27 into 3 root 3.
And then this part's 3, so it's 3 root 3. I like it. Now I'm going to rewrite 3 plus and minus 3 root 3 over 6. How many of you got at least that far? Good. You still don't get full credit yet. Stella, you know what happens next?
Would you multiply it by 3?
If you want to, there's a way to say it like that, so I'm not sure if this is what you mean.
No, 3 times 2.
Okay, I agree. 3 times 2 on the bottom. Can you tell me what goes in the parenthesis, though?
1 plus or minus. And then, I don't know if it's the 3 root 3 or just,
You got to take a 3 out of both of these. Both 3's have to go.
so just the 3.
Yes, it is. and that cancels, and there's your final answer. Who got it that far? Nice. Okay. Dang, you're getting close. So what else is on this test? Well, basically, not too much. And we get to learn how word problems can kind of be built into these. So they can, like, say, we're throwing a ball in the air, and then it turns into an equation, which you can then use the quadratic formula to solve. All right. So let's go through our notes now. I think I've taught you everything you need to be able to be a rock star at this. If it has one root, it'll look like this or this. You get why? Because it hits there, and this one hits here. It could have one root. It could have two roots. It'll hit like this. It'll hit twice. Next page. It could have real roots, but look how they don't touch at nice spots. Did you guys know that these spots where it touches like this, those spots have a name? Does anybody in the whole room know the name for the spots where the two little lines on graph paper touch? Yes. Oh, that's an interesting, I hadn't thought of it that way, but there's a name for the spot on the graph. Yes, they are rational numbers, you're right, but they're called something points, the spots where it crosses. I had to look it up because I didn't even know what they were called, but these roots aren't at those spots. Those spots are called lattice points. These answers right here, they're not at lattice points. So they aren't rational. You're right. They're irrational. Okay, and that's the kind where you can't factor it. Can the quadratic formula still do it? Yes. Quadratic formula can do every one of them. Okay. Or it might just not touch at all. That doesn't mean you don't get an answer. That means you get an answer with what kind of root? If it's like this and it doesn't touch, it has a special kind of root. Good? It's at a negative square root in the problem, like this. And therefore the answer is an I answer, and therefore the answer is imaginary. This kind, it's kind of like cheating. Mathematicians said, oh yeah, it has roots. They're just imaginary. Seriously, it's that made up. But it's actually true that if you don't use imaginary numbers, then there's certain mathematical real-world equations that you can't do. So there's actually electricians who are like designing the most complicated cars in the world, run on electricity, and are, you know, like this is a new thing within the last few years anyways. So they have to have those equations with imaginary numbers in them to do the math. So it's weird that an imaginary thing is necessary to use real-world electricity. So it's kind of a strange thing that imaginaries actually matter. All right, now I'm going to give you the bonus one that I think only, I'm going to say 4 people in this room are going to figure out. See if you can be the kid. It's not incredibly hard, but it's going to take a little twist that I'm not sure many of you are ready for. Square root of -10 all over 6. Can you handle it when I put everything together into one problem? I'll pause for a second, give it a shot. All right, if it didn't have this negative, I'm going to show you what it would be. 2 plus and minus the square root of 10 over 6, and then you'd go, that can simplify to what? Dang, that doesn't simplify. So then this would just be the answer. Because the square root of 10 can't break down into like, you know, root 5 and root 2. So that I'd just be done. So then the only thing that's different is that. So then what's the answer, Kiernan?
2 plus or minus I squared root of 10 over 6.
Yes, so all you really did is took the negative out and put an I right here. And then you were right. That was it. That's all you have to do. And it's simple because it's just saying, I recognize that there's a negative under the root, and that can't really be in the real world, so I'm going to put an I out here to signify that we've got an imaginary answer. All right, I'm going to have you get one more, a bit more complicated since I kind of already given away the ending. This one will simplify more, and it'll have an I in it. So you've gone along and you've done your problem and you get 6 plus or minus the square root of negative 32 all over 2. This time, it simplifies and you got to put an I in just the right spot. See if you can do it. This last part will need a calculator. Not for this one. Try putting in square root of negative 32 on a calculator. It'll just go, eh. It'll actually probably say domain error. And basically it's saying you can't do that. So we won't use a calculator on this one. But here's what I hope you did. I hope you saw that that was the square root of 4 and the square root of 8. But wait, there was something better. Did anybody notice something better than what 4 root 8? 16 and 2 is better because if you leave an answer with square root of 8 in it, it has to get factored all over again. So you had to go all the way down to 16 and 2 and the square root of negative 1, which we're going to give a name to. It's going to be called I. So now I got 6 plus and minus 4I root 2 all over 2. I guarantee you there's some people that aren't even showing their kids this today because they think it's too hard for them. And I'm trusting you that there's a few of you that can do this. That's a 4. That's an I. Okay. And then you'll go, 2 goes into both of these. So I'm pulling it out. And it's 3 plus and minus I root 2 all over 2. 2's cancel. Final answer. Who got that far? 3 plus and minus I root 2. Nice work. Weirdly, the middle of the classroom must be getting better oxygen because they all had it right in the middle. Question?
Wouldn't it be 8 plus or minus 2I?
Oh my gosh, did you just get me? I'm going to double check that. 3 comes out of this. Oh crap, 3 doesn't come out of that. 2 comes out of that. So then 2 comes out of this, and you're right, there's a 2 there. Dang it. Sorry about that. 3 plus and minus 2I, or I2, it actually wouldn't matter either way, root 2. That was so hard, the teacher just screwed up. So, yes?
So, like, what if you, like, provided, like, a different number?
Oh, if there had been, like, what if there had been an 8 on the bottom? Do you get if there had been an 8 down here, there still would have been a 2 buried in it? And if it had been an 8 on the bottom, you asked about a different number, right?
No, like...
You mean like 7 or something weird?
So if it's like 32?
Okay, if the bottom had been like 32, then there still would be a 2 in it, right? I'd cross off my 32 and I would have said 2 times 16, and then that would let the 2 cancel.
Okay, thank you.
So if there was a bigger number on the bottom, you could still get a 2 to factor out of it, probably, and then make the 2 cancel. All right, I know that got really complicated. Let's get on to the last part of the notes where we can be finished. How does we solve for these roots and x-intercepts? If the results are rational, we can factor it. If they're irrational, we have to jump straight to the calculator, and that's not really true. Because if you have an answer like 2 plus and minus the square root of 7 all over 6, that is a good answer all by itself. The teacher who wrote this is saying that you have to go to the calculator to get the answer, but this is the answer. If you go to the calculator, you're going to have to round the decimal. What's cool about this is I don't have to round anything. This is it. It's the answer. It just looks complicated. Now, some people really like decimals, and so they want to get the calculator answer. And I think on the test, you're going to have to do one where you have to get the decimals for it. So let's do that together. Right now, everybody, we're going to do 2 plus and minus root 7 over 6 and see what the 2 answers are. Well, the first thing you got to do is figure out what the square root of 7 is. And don't worry, I'm not going to make you have 17 decimal places. Would you find the square root key on your calculator and find the square root of 7? If you need help finding it, it looks like this. The square root of 7. Did you find it? Kieran?
Yeah,
What'd you get?
I got 2.65.
Let's say 2 decimal places are enough. Okay? So 2.65. Now, everybody does 2 plus 2.65. Remember to hit enter before you hit divide by. I want you to just see why. Because if I say 2 plus 2.65 and then say divided by 6, it'll only divide the last part by 6. You got to hit enter to get this part done first. That happens anytime you have a fraction. Get the whole top part done, and then hit divide by 6. And then we'll do it 2 minus 2.65. All of that divided by 6. That one and that one are your 2 answers as decimals. What'd you get?
I got 0.78
Good enough? And?
and 0.11.
Now, I'm not going to be surprised if you made a mistake. Not you. I don't know if you did, but if a kid made a mistake in here on this, if you think he made a mistake and you got a different answer, would you please tell me? Because maybe he did.
I mean, it's 0.183 repeating.
I hear you. You rounded it, and that's totally okay. Can anybody verify these 2 answers? You got the same thing as he did. There's a bunch of heads nodding. Okay, so let's just make sure you really get this. You get to the end, you get this answer. Will you be able to type it in properly? 8 plus and minus the square root of 11 all over 2. Everybody get the 2 answers using the calculator, rounding to 2 decimal places. Sometimes the kids like to see exactly what keys would you type in to do this. I would start with the 8, of course. And I would start thinking about the plus. Because, you know, I got to do it twice. Once with the plus and once with the minus. So I'd, of course, type 8 plus. And then there's a square root key. And then I'd hit 11, and then I'd hit equals. And I get my answer first. I got to get the top done. And whatever that was, then I go divided by 2. And that's my final answer. Lydia, what did you get for the one where you added square root of 11?
5.66.
Anybody verify 5.66? Yep, a lot of hands. And how about the one where you minused, Kai? What'd you get?
You want me to tell you?
Yeah.
How?
No, not exactly how, just the final answer.
2.34.
Can anybody verify 2.34? A lot of people, yes. Okay, good. Those are my 2 answers. If you didn't get how people just got that, like if you were like, oh, I didn't get that, please let me just show you on the calculator. It takes one minute to show you, okay? Got to be able to put them in the calc. Much harder thing is to simplify them, so I'm going to end with one of those. 10 plus and minus square root of 8 all over 4. My day will be complete if I can get even 2/3 of you to get this right. These are hard. So if that first part is 2 root 2, then it's 10 plus or minus 2 root 2 over 4. And you realize there's 2's all over the place. And then you go, oh, so the 2 factors out of the top. 5 plus and minus root 2. It's that spot right there that usually gets people. If you're not sure if you did that right, just multiply this top out and see if it's right. 2 times 5 makes the 10. And 2 times the root 2 makes 2 root 2. So it's right. And these cancel. 5 plus or minus root 2 over 4. Raise your hand if you had that one right. Oh, dang it. Oh, it was, 4 was 2 times 2, so it's over 2. The top was the hard part to get right, so sorry about that. So who got that one right? Raise your hand if you did. Okay. And that is 2/3 of the remaining. And if you have to do it in the calculator, you just have to get the decimal for that. And go 5 plus it, get the answer, divide by 2. And then 5 minus that, get the answer, divide it by 2. Okay, cool. This just sums up how you do that, which I already did with you. And I feel like you're in a good spot. So we're not going to do all of those practice problems because we did different ones. Your homework is on today's page. And I'm going to pause for a second. It's called U8L2 and U8L2 worksheet. The first problem is 4x squared plus 11x minus 20 equals 0. Good. And you just basically use the quadratic formula to get the answer. Now, I think you don't really need 8. So I think I'm just going to say everybody cross off problems 7 and 8. And if you did 6 of them, that'd be plenty. Let's look at number 3. It's the first one that looks kind of weird. Everybody look at problem 3 with me. Josh, can you read me number 3, please?
X squared equals 3x plus 3.
This looks different than all the other ones we did. Do you know what to do? They are supposed to be set equal to 0, so what are you going to do?
Minus x squared on both sides.
That would work. Now, I know some people are going to say a different thing, but Truckee, you're right. 0 equals is also a way you can do it. Negative x squared plus 3x plus 3. That works. And now the only weird part is you have a negative 1 for your a. Now, another kid I know, I could hear him, was going to say we subtract 3x. And that would have worked. And it would have said x squared minus 3x, and then we would have minus the 3 also. And this is kind of strange, but this and this are exact opposites, and yet they still work. That is weird, but true. One's got a negative x squared, one's got a positive 3x, one's got a negative 3x, one's got a negative 3, one's got a positive 3, and they're the same. The reason? Because you could multiply both sides by negative 1, and it would go to the other way. So this equation and this equation are exactly the same. It's so weird. You can go through and make everything the opposite, and it's still true. Because it's equal to 0, and at the end, opposite of 0 is still equal to 0. Okay, so what that means is, when you have a problem like this, you got to set it equal to 0, but it doesn't matter whether you move the x squared to the other side or move the 3x and the 3 to the other side. It doesn't matter. Do it either way. Okay, problems 1 through 6 on the worksheet is all I got for you. Have a good day.